Welcome back, everybody. In this video, we will be covering the first half of Lecture 11. The topic of the lecture is the binomial option pricing model. Okay, let's get started. Up until this point, we have not made any assumptions about the distribution of stock prices. No arbitrage. That assumption we had that prices do not permit arbitrage alone gave us upper and lower bounds in option prices. We learned about this in lecture 10. And put call parity provided us with the ability to calculate call prices from put prices and vice versa. Okay, we also learned about this in lecture 10 as well. We now want to take the next logical step. We can bound option prices. We can calculate option prices given other option prices. What we now want to ask is, how can we calculate the exact option prices in isolation? To price options, we need to make assumptions about the distribution of the stock price. That is, we need an economic model of the underlying asset. For most cases, this will be the stock when we discuss it. In this lecture, we're going to start with the simplest possible model. It's called the binomial option pricing model. The binomial model assumes that over a fixed period of time, the price of the stock or the underlying asset can either go up or down by a specified amount. Okay? The stock can either go up or down. It cannot take any values above, below, in between these two different values. In other words, the binomial option pricing model assumes that the return on the stock follows a binomial distribution. The model sounds really simple, and we'll see that it is really simple to implement. However, despite this simplicity, this is one of the most widely used models in practice, or extensions of it at least, and this is because it possesses several desirable features. It's going to be able to price all sorts of exotic and American options, as we'll see in Lecture 13 or Lecture 12. It's also going to have a lot of nice computational properties, and the logic is intuitive, and we can understand what's going on behind the scenes. In the first part of this lecture, we're going to lay the groundwork for the binomial pricing model. We're going to show how stocks and bonds evolve in the model, and we're also going to do a practice problem to reinforce our understanding. We'll then split the lecture up into three more parts. In the second and third parts, we'll learn how to price calls and puts using the binomial option pricing model. And in the final fourth part, we will discuss these two auxiliary topics, which are arbitrage opportunities and a little insight about something that we'll learn called the options delta. Okay, so let's get to work. Our setup's going to be mostly the same as usual, albeit a few slight changes. We have a non-dividend paying stock, S. The price of this stock today is going to be S0. It's known. And the payoffs are going to be random in the future. And we're going to impose some particular structure on them in a second. We have a continuously compounded risk-free rate that's available for lending and investing. This rate is greater than or equal to 0. And we have two dates in the model as always, two dates 0 and t. Okay, date 0 is today, date t is the future. We know everything today, but we don't know about the future. What we're now going to do is make some assumptions about the structure of what can go on at date t. We're going to impose some structure on the randomness that can happen at date t. Specifically, we're going to assume there are two possible states of the world that can occur at date t. First, there is the U, or the up state, and second, there is the D, or the down state. Okay, we can think of the U state as something like the economy's booming, and we can think of the D state as something like, say, the economy is suffering, say the coronavirus. Okay, the payoff to the stock is going to depend on which state of the world is realized in the future. When the economy is booming in state U, what we're going to have is that the stock price is going to be equal to S sub U. This is going to be equal to today's price, S0, multiplied by some constant U. And here the constant U is going to be a gross rate of return, not a net rate of return. and it's just equal to the ratio of the price tomorrow over the price today. Okay, so say the stock can move up from 1 to 2, then U would be 2 over 1, which is 1. Okay. In the down state, the stock price is given by S sub D. Remember, this is the economy is potentially suffering state. S sub D is equal also to today's price multiplied by some constant D, where D is the gross rate of return in the down state. It's S sub D over S sub 0. So for example, if the stock is $1 today, it can move down to 1/2 in the D state. Then the value of the gross rate of return is 1/2 over 1, or 1/2. Finally, we're going to assume there's no arbitrage. There's some technical conditions for when this holds. These technical conditions just mean that no arbitrage happens whenever the risk-free rate falls between the two gross rates of return, the return on a risk-free investment, that is. Okay? This is kind of abstract. I prefer to look at the binomial model visually. I think it's the best way to understand it, and we'll do so with 3 slides. Okay? In the binomial model, there are 2 states, today, date 0, to the future, date t, no different than what we've been working with in class so far. Everything at date 0 is known to us. It's a singleton point right here. We know exactly what's going on. However, there's uncertainty. Okay, there's uncertainty over the future state of the world. Okay, so everything is known over a date t, but there's uncertainty over what's going to happen in the future. The binomial model, the feature of it is that it imposes a particular structure on this uncertainty. It's going to say that there's either 2 possible outcomes at this future date. There's either the upstate, U. Think of this as the economy is booming again. We'll say it's like boom. Or there's the downstate D, which, for the extremes, we'll think it's bust, financial crisis. Okay. Then what we do is we have this binomial model. We have one date today. We have a future date, capital T, where payoffs will occur. There's uncertainty over what's going to happen at date T. And then what we do is we slowly take this setup and introduce our assets one by one. Eventually, we'll add options to this model, and we'll see how we're able to price them. Okay? And so first, let's think about adding the stock to the model. So the stock's price today at date 0 is known, okay? And it's given by S0. This is our first asset in the model. We have 2 assets, the stock, the bond, and eventually we'll have options in this model as well. The stock's price today is known, and its payoff is going to be random in the future. It's a risky asset. And in particular, like we said, the payoff is going to depend on the state of the world as realized. In the upstate of the world, okay, the upstate, what happens is that the stock price can take a value of S sub U. This value, S sub U, is equal to today's price times this gross rate of return. Okay, in the down state, the stock takes a different value potentially. Its value is given by S sub D. This is equal to today's price S0 multiplied by this gross rate of return in the down state. In most cases, we'll have that U is greater than D. We'll order the states in that way as long as it's a positive beta asset. Okay. So in these 2 states, the stock has a different payoff in each state. Our other basis asset is a bond, and the unique feature of this bond is that it has the same payoff in every state. That is, what we have is we're given a risk-free rate of R, okay? And what we're going to assume is that we can invest in bonds that pay the risk-free rate. We've done this all throughout the class so far. For the forward, we invested in a bond with a face value of K. We're going to just consider, however, bonds, in this case, with face value of 1. We're going to have discount bonds. They're going to have face values of 1, and their asset structure is going to be denoted as B. Okay? Since this bond is risk-free, its payoff is going to be constant in all states of the world. Okay? So in the upstate of the world, the bond's payoff is B sub U, where B here is risk-free bond, risk-free discount bond with face value $1. Okay. In the upstate of the world, the payoff to the bond is B equal to 1. And in the downstate of the world and the economy's bust, it's going to be 1 as well. The bond is going to be risk-free. The feature of a risk-free asset is that its payoff does not depend on the state of the world. You know for sure what the cash flow is going to be tomorrow. Okay, this bond pays off 1 in both states of the world. So the price of this bond is just the $1 discounted at the risk-free rate. The bond's price today, if you want to purchase one of these discount bonds, is just denoted B0. It's equal to e to the negative RT, where R is the risk-free rate that we're given, T is the maturity. Okay, so to recap, what do we have? We're just introducing ourselves to the binomial model. Later lectures will then use this model to price, call, and put options. To refresh, we have two basis assets in the model. We have a stock and a bond. The stock has a price today of S0, and its payoffs are random and depend on the future state of the world. The main assumption behind the binomial model is that the future states of the world, there are only two. Okay, and the stock's payoff varies based on these states. There's an upstate which corresponds to a booming economy. There's a downstate that corresponds to a bust economy, and the stock's payoff in the upstate is S sub U, and in the downstate it's S sub D. Our second basis asset is this bond. The risk-free bond is for face value 1. We can buy as many or sell as many of these as we want. The payoff to this bond is always 1 in both the upstate and the downstate. The price of this bond is just the price of a risk-free cash flow of 1 at date capital T. It's e to the negative RT. Okay, so to get some practice with the binomial model before we move it right into option pricing, we're going to do a practice problem. I'll give you a minute to read this and then I'll solve it. The basic setup here is we just want to learn how to move around with the binomial model and to learn about which assets are which. So I'll give you a second and then we'll solve it out. All right. So this problem, like I said, is going to help us learn the mechanics of the binomial model. I'll read the problem statement and we'll work through it. So we're in a binomial world. There are two dates, 0 and capital T. Okay. And at date T, what we have is there's two possible states, U and D. The physical probability of state U occurring in the future is P equal to 0.5. And we have two assets in the model, X and Y. Asset X is going to have a price of X0 equal to 2. Its payoff is going to depend on the future state of the world. In the upstate, it's going to be X sub U equals 4. In the downstate, it's going to be X sub D equals to 0. Asset Y is going to have a price of 90 cents, and its payoffs are going to be constant in the future state of the world, and it's just going to be equal to 1. Okay. What we want to do is we want to look at these assets on the binomial tree. We want to ask which asset is the stock, which asset is most like the bond. Calculate the continuously compounded risk-free rate. This is going to be as a function of T here. And then we're going to calculate the expected gross return on the stock. Okay, so let's add this all to our binomial model and write down the inputs. Okay, so we'll start by drawing our binomial tree. We have two dates. Today is date 0. The future is date capital T. We'll make an assumption about what this is in a second. Okay, we are at date 0. What's happening at date 0 is known to us today. It's a singleton. But with the binomial model, there are two possible states of the world in the future. Okay, there's the upstate. Okay, and the downstate. Okay, we have two assets, X and Y, in this model. The first asset, X, has a price today of X0, and it's given to us that it's equal to 2. In the up state of the world, the payoff to this asset is XU equal to 4. And in the D state of the world, the payoff to this asset is XD equal to 0. Our second asset is asset Y. The price of asset Y today is Y0 equals to 0.90. Okay. The payoffs to this asset are YU equals to 1 in the up state. And in the D state where the economy is bust, it's YD equal to 1. We're given a physical probability of each state, that is the likelihood that each state occurs. Normally we won't be needing this as the magic of the option pricing model, but for now we'll work with it. We have that the probability of the upstate is 1/2, and since probabilities have to sum to 1, the probability of the downstate has to be 1 minus P, which is 1/2 as well. Okay, so we start with the first question here, which asks which asset is most like the stock, which asset is most like the bond. So we know that the risk-free bonds payoff should be constant. Okay, if we flip back a few slides, the risk-free bonds payoff is constant. Okay, it does not depend on the state of the world. Okay, and so an obvious way to look for which thing is most like the bond is to isolate or identify which asset has a constant payoff. Okay, asset Y seems to have this property, while asset X's payoff depends on the value of the state of the world. Asset Y's payoff stays put at $1. Thus, what we can conclude is that Y is equal to the bond, asset X is equal to the stock, and so we'll also calculate from this the gross rates of return on this stock. Okay, so what we have here is that X sub U is equal to the payoff, okay, of 4. Okay, we know that the stock has the payoff structure of U times its price today, U times X0. This is going to imply that U is equal to X sub U, 4 over X sub 0, 2, which is 2. And in the D state of the world, the payoff of this stock is 0. This is equal to D times X sub 0, which implies that D is equal to 0 over 2, which is 0. These are gross rates of return. If we want the net rate of return, we just subtract 1 from them. Okay. In the second part of the question, what we want to do is calculate the continuously compounded risk-free rate. Okay. So we know that asset 2 is the bond. Okay, so let's look at it here. So I'll draw it in green. We know that asset 2 is the bond. Okay, it has constant payoffs of 1 in each state. And we know that the bond's payoff from the slides before has to just equal the discounted present value of the $1 payment. It's e to the negative r times t. Okay, so to calculate what the risk-free rate is, all we need to do is solve this one equation, one unknown. Okay, so we have that y0 is equal to 0.9. It's actually going to be 2 unknowns, is equal to the discount bond price e to the negative rt. Okay, this means that if we take natural log of both sides, negative r times t equals log of 0.9, which implies that the risk-free rate in this model is just negative 1 over t log of 0.90, where 0.90 is y0. Let's just make an assumption just so we can compute this on what value t is. So capital T, say it's 1 year. Okay, then what we would have is that the risk-free rate in this model would be negative 1 over 1 log of 0.90. Okay, this is roughly equal to 10%. It's a little over, it's 10.54%. Okay, or we can write it's 0.1054. Okay, so once we know which asset is the bond, and say we make an assumption about what t is, say t is equal to 1, we can easily calculate the risk-free rate in the model if we're not given it. You just take the natural log of the bond's price, and then you divide it by negative 1 over t. Okay. In the final part of the question, what we want to do is calculate the expected gross return on the stock. We're just learning about the mechanics of the binomial model. We won't use many of these practice questions again right here, but we're just trying to think and play around and see what we can calculate before we move on to options. We want to know what the expected gross return on the stock is, which, if you remember back to probability, is just the probability weighted average gross return. Okay, so if you want to get the expected gross return, okay, on the stock, what do? Okay, remember that the expected return on anything is just the probability weighted average gross return. Okay, so if we want to think, say we denote the expected gross return under this physical measure as E of R, okay, just like in CAPM, then what it's going to be is it's going to be the probability, okay, probability of the upstate times the gross return in the upstate, which is U, plus the probability of the downstate times the gross return in the downstate, D. The probability of the upstate is given to us. It's P in this slide back here. It's 1/2 times the gross return in the upstate, which is 2. The probability of the downstate is 1 minus 1/2, or 1/2 times 0. So the expected gross return is just 1. Okay, which means that the expected net return, okay, the expected net return, R minus 1, is just equal to 0. Okay, so that wraps up the first third of this lecture. It's just an introduction to the mechanics behind the binomial option pricing model. The main thing to take away is just the graphs, not necessarily the practice problem. We just know now that we're imposing a particular type of uncertainty on the stock price process, okay, a particular type of structure. Stock price can either go up or down, can't take any values in between. We have a second asset, which is a bond, whose payoff is constant in both states of the world. What we're going to do now and see that just these minimal amount of assumptions, we're going to be able to do a lot of different types of pricing. We're going to be able to price call options, put options, and as we'll see in lecture 12, it's any general type of option. Okay, so let's take a quick break. We'll resume the lecture in the next video.